Welcome back, everybody. We are on stream maybe 7 or 8 of getting shape key animation support into the engine. So I am making a game engine in C++ and Vulkan. I've been working on it for many years now, me and my husband, and we're finally almost to the point where we can make a game, and I feel like those are famous last words, but we have made a game with it before. We made a Game Jam game for the Pirate Software Game Jam in 2024, and it was great. It worked. It was awesome. But we've gone through a couple changes since then. Actually quite a few changes since then, but I've talked about it in other videos, so I'm not going to blab on about it now. But let's summarize what we've done with shape keys so far briefly. So shape keys are, you can think of them as a different way to animate besides the traditional skeletal animation. It's just a copy of a mesh at various positions. So I have 3 shape keys in this mesh, 1 at this position, 1 at this position, and 1 at this position. And you can animate over those. Now, in order to get shape key animation support into the engine, we have to do quite a few things. So step 1 is we need to get this data out of Blender and into some kind of data format that we can deal with. So we export as a GLTF or a GLB, and then we use ASIMP which is Asset Importer. It's a really cool open source library to go from GLTF to NCA format. And I believe that's done. NCA is just our custom format. So I think that's mostly done. I'm kind of going at it from different angles here. So going from GLTF to a format that we can work with, I decided upon this structure which models the skeletal animation, and it's pretty close to what, well, I guess I was going to say it's pretty close to the shape key data structure that ASIMP uses, but that's really not true. I've taken a bunch of liberties, just stealing the position frame, the meshes that I need instead of grabbing all the data and lerping between it. I'm just stealing the ones I need and then hoping for the best. So there might be some data loss. There doesn't seem to be so far. But anyway, I have successfully gone from Blender to GLTF to this format. So that work is done. And this kind of ends in parsing this struct out of the file. Then the next thing to do, which I've already done, is we need to serialize this into an actual .nca binary format. We did that. That's done. Now the next stage of the pipeline, which I am working on right now, is to then take the NCA format, and so essentially the idea with the assets is you want to be able to offline create a bunch of different assets, and we have this converter tool that we use to do that, and that creates the NCA file. And then when you're running the game or the engine, you want to be able to load those NCA formats into memory. So the loading the NCA format into memory is what I'm working on now. And then if you've seen the last couple of streams, I've been working from the other way inwards as well. And so what I did was I hard-coded the data structure that comes out of ASIMP in the shape that I'm expecting it to be in, so that I can then go from the shader. I can show you that. So I can go from the shader and lerp between the keys and apply the offsets and then validate that the shape is suitable. And I've actually ran into a small amount of problems doing that, and some success. So I can show you the success. Right now this is just hard coding the shape keys that I parse out of Blender using our converter. So this is our plane being morphed, which is really exciting. I think this is the first time on stream I've actually shown the thing working. Look at that go. Pretty cool. And again, that is this. So I validated that the data structure, well, I would like to say that I validated that the data structure is what I need it to be, except that when I turn it on for this guy, which I can't easily do because everything's hacked in there right now, things go absolutely crazy. It's as if the vertices in the shape key format don't match with the vertices that are being iterated through in the vertex shader. And I don't quite know how to solve that problem yet. It might just be that I have corrupt data in this cube that I've been working with. Or it could be that my assumption that outputting, using asymp to output or to import GLTF as a mesh and using asymp to import a GLTF as a shape key vector, I've been assuming that that would preserve the order of the vertices, but if it doesn't, then I don't know. That'll be a lot of work to try to fix. It seems like it does, although with a plane like this, it's not a very good test case to prove that it does. Because this corner going out here could be this corner. It could be this corner, or it could be this corner, or it could be this corner, or it could be this corner if the vertex order isn't maintained. So let's see here. So I have the data structure that I need, I think. I have the data structure hacked in. Most of that will be throwaway in the shader. I'm going to pass the data to the shader in both a texture array, and the texture is just a good data structure representation for the vector of vertices, the vector of vector 3s. I think each float in the vector 3 can be R, G, or B, represent a 3-channel image. Then you can have an array of those 3 channels, so that'd be one row of the image, and then so one row represents one shape key, and then if you have 40 shape keys, that's just an image with 40 lines in it. So that I have that data structure, that buffer of texture array already mapped to the shader, and then I also need a metadata buffer, which I've already created, that will link the mesh buffer, and that's not the vertex buffer, but the instance buffer, you could think of it as. Can I show you that actually? Oh, this right here. So each instance of a mesh has its own index into right here. It's going to have its own index into the array of textures to get the proper shape key animation clip. So each texture in the array will represent an animation. So I have that data structure created. So we're getting very close to being done. As you can see, I've kind of started at the end and at the beginning, and we're kind of converging into the middle. I don't get a whole lot of time to work on it, but we're making our way. I think the number one trait you need to be an indie dev of any kind is just
125 chroma bit.
Oops. Trying to check my stream to make sure that my audio is working and such. Okay, good. I think that the only trait you need if you want to be an indie dev is just persistence, and you need a lot of persistence. But I've always been bad at math, and I feel like C++ was a very, very, very long road for me, because for some reason, maybe it's just that it's a little bit more explicit than other languages, but it just takes a long time to get your head around all the different concepts that exist in lower level languages that don't exist in higher level languages. So by day I'm a .NET developer, a legacy .NET developer, so I don't have to deal with a lot of memory management or pointer versus reference or R value and L value reference, any of that. But I'm mostly there. I know enough to be dangerous in C++. I've been doing it now as a hobby for a long time. But all that to say, you don't have to be an expert to make your own game engine. You just have to be persistent and be willing to start from scratch or redo things when they're not meeting your expectations. And another nugget that I've found is don't worry about something not being good enough. Literally, you get to decide what's good enough, and period. So if it does what you want it to do, then it's good enough. Which I think is really freeing once you learn that. Oh, and I forgot to mention, I am listening to Lost in the Forest. A couple weeks ago I encountered a Reddit thread where people were giving away their or permission to stream their Dungeon Synth album. So this one is Lost in the Forest is the creator. The album name is Forgotten Lands. It's very, very good. Okay, so let's get into it. So I'm back to starting from the beginning a little bit because we've done a lot of the end. So I am working on importing the asset into memory right now. Okay, so we have, let me grab it. We have in the NCA this shape, and what we need to do is we want to upload textures and we know we also need a way to capture this data. So in the this is all hard-coded. What we're actually going to do is we're going to say if the shape key, we get the shape key metadata index, and what that's going to point to every mesh instance will have a shape key metadata index. Okay, so the asset data, it's really a texture with an ID and then we're going to have duration in ticks. I don't know if we need the shape key count. I'm sure we did. At some point. Okay, so really what I want is when we get it out of ASIMP, we don't want it in this shape. We want it in this shape. So we don't know there's going to be 3 channels. And we want a stood vector. Position data. Numbers will be the width. So every vertex will represent a pixel. And then the num shape keys will represent the height. That I don't need both of these, I just need a duration in seconds. No, that's a good shape to work with. So let's go back to the geometry. Now we're going back to how we get it out of the actual GLTF file and into our format. So we're changing the format, which is why you don't want to solidify anything until you have enough of the pieces fleshed out, which is why I took this approach. So you don't want to tighten the screws completely until all of the screws are tightened a little bit. Okay. Convert to shape key animation, and now the data structure looks like this. So the duration in seconds. Okay, 500 ticks and 3 ticks per second. You have 500 divided by 3 is your number of seconds. I want it in seconds because I'm going to be passing the elapsed seconds to the vertex shader. And the elapsed seconds will then tell us what, so say 1,000 seconds have elapsed since start of the game. And let's do 1,003 seconds have elapsed since starting the game. And my animation clip is 10 seconds long. Then you can just take 1,000 modulus 10, which would give you 3. So it'd be 3 out of 10 would be the index into my clips, my shape keys. So roughly 1/3 of the way through. Okay, so duration ticks divided by ticks per second. Shape keys. we're going to do some Googling to figure out how to fill a care array. So manually create a texture care array. What I'm wondering here, so I'm looking at the STBI format. Here, which is just a stood vector of characters and a width and a height. So I'm assuming it's just calculating the stride itself and it's not actually a nested vector. So that should be fine. If we know the number, the width and the height, then we can just have one long string. More Googling. Okay, so what I'm confused about now is, so the internet tells me that it's going to look something like that would be 3 pixels, and then if you had, let's just say you have a 3 by 3 square, it would then look like where these would obviously be like, and so forth. I'm just not going to make 9 of them, but maybe I did. This would be something like 255. This would be 17, so your first pixel is right here. So okay, that makes sense, but what doesn't make sense is I'm trying to represent floats here. Stack Overflowing. Yeah. Image data. So I have to rethink this a little bit because I don't want RGB because those are U integers. I want a format like this. So in that case, I need to figure out the image format for storing floats as image data. For storing floats, I think it's R32. This is what we did for depth when we wanted to store floating point precision. Image format for storing floats. As image. Okay, it looks like I want this. VK format R32S float. So then position data will be something like 0.1, 2.0, 1.3, and that's going to map to X, Y, Z, X, Y, Z. So that means my float. Be right back. Bathroom break. We are back. So a little bit of a derailment here, trying to figure out how to make a texture image with floats instead of RGB. But I think that's the format we want. Now, num vertices times times 3. And then num shape keys is still just the height. Okay, so we take that back to geometry converter here. Okay, now that's making more sense. So num shape keys is still the height. And we want to do auto position offsets per key. So that will just be a single row equals std vector of float and that reserve now we want to reserve the number of vertices, so that's going to be fixed. So we already got num shape keys as the number of num and meshes. And we already know it's going to be at least 1. So, and we know that for each anim mesh, the number of vertices will be fixed. So that means we can safely reserve by saying mesh to m anim meshes 0, which will get us the first one, dot m num vertices, so that will give us the number of vertices, but we want, let's see, that would be vector 3, so we want to multiply by 3 to make enough room for each separate float, times 3. And then view vertices, what does that return? A span over AI vector 3. Okay, then we want to, let's just make this our position offsets vector of floats. So then times 3u times num shape keys. Shape keys. Okay, so We want to reserve. Already did that. Okay. So now we have to fill this thing. So for each animated mesh, position. Let's just go right into it. I don't know why I'm making it temporary here. Shape animation dot position offsets here. Okay, so then offsets. I don't want to do that. I'm gonna make a new helper called convert to floats, and it takes this span of vector 3Ds. And it's going to output a vector of float. Okay, the out vector is the vector of float. Times 3. Can you do a multi-part transform? No, I don't think so. Okay, well, let's just do it inline. Okay, so position offsets dot push back. Okay. Do they require? Yeah. When in doubt, take by constref. I could just do this because this is going to return a span, which is just what I want. It's just what I want. I don't know if I can do that in line. It's in place. Let's try it. Namespace it. That's awesome if that actually works. I feel like it's not going to. C++ has never let me down in when I expected not to work. Okay. Then we are going to position offsets dot pushback vertex dot x vertex dot y vertex dot z. It's called position data. We were so not going to compile. IntelliSense has absolutely given up. Okay, we're not in a Lambda context, so I should just be able to reference it directly there. Okay. For each animesh. Oh. I can just do this, but I guess it's a little bit more nicer to do that. I think it will work then, because that's exactly what it's returning, is this shape, except for over my vertices. Okay, position data. Dot pushback. Are you a float? Tell me you are a float. I'd be able to deal with it if you were not. Yep. Can, if NC vector 3 can grab it. Yeah, okay. You are afloat. Let's try it. You know, I don't think I'm in a position to build anyway with... That's the bad part of starting from both ends at the same time. Okay, that's better than I thought. Oh, you should be afloat. You're right, thank you. I feel like I move around too much for my green screen app to work. I might go back to just the square here next time. I just temporarily prevent you from doing anything. I think, yeah, the only thing that's broken is my update event data, and that happens when we are trying to load an NCA into RAM. I really don't like the unused reference error. I feel like it only happens when I'm part of the way through being able to debug something. So I've partially implemented something and it's literally the only time I ever see it. I'm gonna start my music again. This is Forgotten Lands by Lost in the Forest, and it is very good. Check it out on Spotify. I feel like we're getting reasonably close. This has got to be one of the longest things one can do in the game engine, which is create a new asset format, because it touches the converter tool. You have to parse it out of the whatever raw data it came from into our format that we can deal with, into a structure we like. Then you need to write code to serialize that and deserialize it so that you can keep it around and you don't have to convert it every time you want to use it. Then once you deserialized it into RAM, then you need to create all of the buffer backends and shader code to interact with it. But you also, in our case, we have this management system, asset manager system, that handles loading and unloading from memory these NCA files. So we have to get those fleshed out, and they have an event signaling system that lets our shader storage know when There's data to store on the GPU. It's just a whole thing, so it's taking weeks, but we're getting there. Oh, I don't want to get to the engine. I want to debug. I want to debug you. So debug NC convert and go. Oh, that's right, because I actually had, so it didn't do anything. Because the last time I ran it, I had created a serialized shape key. But we know now that it was just in the wrong shape. So if I go into here and delete them, then now it will work. Okay, so what did you give us? 84. Is that divided by 3? Yeah, it is. So that's good. Number of shape keys is 2. Duration in seconds is 0.416. That's about what we expected. Good. Oh, number vertices is 0. That's not good. Oh, yeah. Well, that makes sense. Because I never said it. Okay, 14 vertices. Okay, and what is 14 times 3 times 2? It better be, what are you? 84. 3 times 2 is, okay. You are for the plane. 4 times 3 times 2. No, 4 times 3 times 3. Right. Cool. And 8.3. Wonderful. Okay, now comes the hard part. Let's change the asset format. I'll say asset. Oh. Now that we have this new structure, we want to go back to the... I need to figure out how to get it into... So that's going to into the GPU. So that's going to be here. Oh, okay. Okay. So we do we need the actual... Oh, okay. So I'm assuming that I'm sending it a texture with ID. do I make a new... Here. So this is the GPU backing source that I was planning on using. Shader bindings. Yes, I was. Okay. That's fine. I just have to change the asset data structure a little bit. Not the stuff we just did. If I am going to reuse this. Whip levels would be 1, 2. Okay, that's good. Texture width, height, and format. Texture format. I think everything in here is all that I need. Okay, what point do I make a new texture? Okay, so if we go back, I'm gonna close out everything but this file. Let's go to asset data. Oh, I did, okay. But I really need it to be texture with ID. Oops. So I need it to fit into this shape. What do we do with the ID? Do we do anything? I wonder if this is crazy. This feels pretty crazy. Okay, so then I don't think I need any of this. The question is, do I just change it into duration in seconds and then a texture? Yeah, I think so. gonna be so excited when this is done, because then I'll have this beautiful capability of doing this. Look at that. I cannot wait. It's gonna add so much juice. I've spent so much time on this thing that has very little to do with what I'm actually doing in my game, but that is the freedom you get when you're doing a project for no money. You can do whatever you want. Okay. So, pixel data, how do we get that? Oh no. Okay, you can't be a texture because you're not a care array. Of course. So, what happens? How much work are we talking about if we template this on the type of pixel data? I don't think you can forward declare template instances. I regret this. I don't think this is the way to go. Okay, I'm gonna give this another 15 minutes of going down this road, and then I'm gonna roll back. Wouldn't I need to then... Here. Okay, dude. Templates are not my strong point. Oh, that's a bummer. What happens if we try to just leave them here? I think this one can just be an unsigned car. This would be so cool. This would be literally the best day of my life if this actually worked, but I feel like I didn't vet this approach enough, and here I am tunneling down this road, barreling down. start my own naming conventions here. Further I go down this road of trying to templatize texture, the more hope I get, but I really can't tell you if this approach is sound. Well, we're just gonna have to find out. Oh. Did stand out to me as not looking correct. So I'm doing all of this so that I can have in my assets, I can have a texture of type float here in my shape key animation, so that when I send it to the texture buffer resource, it can just throw it right on the GPU. Oh, okay, we're getting there. The last one, but I don't know what you mean. Oh, because you're down here. that actually works. I very well may cry. Okay, that was not what you wanted. Okay, pretty much everywhere it's going to be pretty much everywhere it's going to be hot. It's going to be an unsigned care. Except for in the asset for shape keys, and then the texture buffer resource has to be templated to yeah, this is where I'm gonna leave you all as unsigned car. This is starting to border on the buffer resource stuff, so this might have to be templated or generic. Unsigned car. Oh, this song's really good. There's zero chance that this works. That would be insane if I actually got it right. I need to have more self-confidence in my templating abilities. You know, conceptually, I understand exactly how templates work. You get a compile time, second definition, or third or fourth of whatever specializations you have defined. Holy... Oh no. Okay. Okay. Celebrated too early.